Okay, let's begin. Today we'll start with object-oriented programming in Python. Uh, do you people have any idea what is object-oriented programming? Any one of you? I think
No, sir.
we had discussed a little about this earlier. I think so. Huh? Do you remember anything? Okay. Okay, no problem. Uh, till now you have done C and a little bit of Python also. What we have done till now is all based on functions, right? Is the screen visible to all of you?
Yes, sir.
Okay. So till now, whatever programming you have done was all based on functions or procedures. The basic idea was to find a solution in terms of functions or to find a solution and divide that solution into set of functions and things. Data was not important. When we talk of object-oriented programming, then data is the most important thing, right? If you think of anything in the world, whether it is tangible or intangible, visible or not visible, everything can be treated as an object, right? Whether it is a pen that you are holding, that you may be holding in your hand, whether it is air, which is not visible but you can see it, whether it is smell, you can feel it but you cannot see it. So all these things are objects, whether they are tangible like pen or a table or a chair, or they are intangible like air or smell or something else, right? Everything is an object. So when we talk of an object, then each object can be represented using two things. One is features, and second is its behavior. For example, if we consider a pen, then its features are uh, type, right? We are considering an object pen, then its features are type, it may be color, it may be material, and its behavior is it is used to write, right? Similarly, if we think of a person, so its features or attributes, we also call features as attributes. So what are the attributes of a person? He may have an ID, he'll have a name, he'll have an address, he'll have an age, and many other features depending on the context. Then behavior, he maybe he can walk, he can talk, he can work, he can earn, he can learn, he can teach. It all depends. So features and behavior, it all depends on the context in which you are going to use it, use the person ID, right? So how you are going to use a person object will define that what will be its attributes and what will be the behavior. So when we talk of object-oriented programming, we need to discuss a few terms: abstraction, encapsulation, then data hiding, then inheritance, and finally polymorphism. These are the main concepts related with object-oriented programming. Abstraction simply means confining to relevant details. Confining to relevant details. As I told you, when we think of a person may have, let me write it again, a person may have some ID, may have a name, may have an address, may have a job, may have a salary, may have some department associated with him, may have an age, and so on. Now, it all depends in which context you are going to use the person. For example, if the person is a student, Then instead of ID, we'll have roll number, we'll have name, we'll have class, we may have okay, age, we may have gender, right? Similarly, if the same person is treated as a patient, then instead of roll number, we may have patient ID, name will be there, right? Uh, Maybe department may be there, or there may be some blood type or blood group may be there. It may be his height may be relevant, his weight may be relevant, and there may be a few things other which are relevant to a person as a patient. Now, when we are talking of student, then height and weight doesn't matter, or blood group doesn't matter normally, right? But when we are talking of patient, then blood group, height, weight, they are very important. Similarly, when we are talking of a patient, class doesn't matter. Gender may matter, of course. So there are a few things which are common for a student and a patient, but then there are a few things which are exclusively based on the context in which you are going to use a student or a patient. I mean, you are going to use the person, right? Okay, abstraction is clear. It is confining to relevant details. Is it clear to all of you?
Yes, sir.
Yes, sir.
So abstraction basically is of two types. It may be data abstraction, means what type of features or attributes we are going to consider. Features, we also call these properties. And second is function abstraction or method abstraction. What kind of behavior you are going to define for a person, or we may call these methods, right? So we need to identify what kind of data we are going to consider for a particular object. Second, we are going to identify what kind of methods we applied on that particular set of data. Oh, okay. Then comes encapsulation. Encapsulation means binding data and methods together. This is the second phase. What we'll do after abstraction, once we have identified what is going to be the attributes or features or properties of an object and what is going to be the behavior, we put them together and make an entity. For example, just like a normal medicinal capsule is there, we put medicines into it and then we close it. Similarly, here also, encapsulation basically means the same thing. We'll identify abstraction, we'll do abstraction first, we'll identify the data attributes or features or properties that we need to consider and the operations which we are going to apply on that particular object. So when we put both the things together, and then that is called encapsulation. Then very important is data hiding, controlling the excess over data. So sometimes it happens that some data is not very crucial, or maybe it can be placed in public domain. We'll make it public, means it is accessible to everybody. But then there may be some data which is private, which should not be accessible to outside world. For example, your password, those should be private. Your bank account details should be private. So we cannot make that data public. We cannot give access to everybody over that data. Is this thing clear? Yes. Is this
Yes,
clear?
sir.
Yes, sir.
So we have abstraction, then we have encapsulation, and then we have data hiding. These are the three very basic concepts of object-oriented programming. Then comes inheritance. Inheritance means creating new entities from existing ones. Inheritance, for example, normally we say that a person looks like his or her father or mother, right? Do we say so? ऐसा होता है? Yes, anybody? Do we normally say
Yes,
that
sir.
that a person looks like his or her father or mother. It means the person has inherited or acquired some properties or visual properties of his or her father or mother. That's why we say it. So, in case of object oriented programming, inheritance is the ability to create new classes or new objects from existing ones. For example, we'll take a very simple example of this. Uh, we can even create a hierarchy of classes. For example, uh, automobile is a high level class from which you can create other classes like two wheeler, and you can create four wheeler. Then within two wheeler, we may have geared and non geared. In four wheelers, you may have uh, manual transmission, or you may have automatic transmission. And you can go on dividing, right? So what happens? Automobile is a very generic concept. We have divided into further two categories, two-wheeler and four-wheeler. It means we are moving towards specialization. Then again, within two-wheelers, we may have geared, for example, motorcycle is there or scooters are there, or non-geared means like Activa is there or all other such vehicles. Similarly, in four-wheelers, we may have cars, right? So within four wheelers, we may have automatic transitions and transmissions, and then we may have manual transmission. So when we say that a four wheeler with manual transmission, it means we are talking about something very, very specific, right? If we talk of only automobile, then it's a very, very generic concept. From this, when we are moving to two wheeler or four wheeler, then we are moving towards some degree of specialization. And from two wheeler, we are moving to geared and non geared, then we are moving further towards some more specialization. So, what will happen? Geared class will be created using this two wheeler, and two wheeler will be created using automobile. What will happen? What is the effect of inheritance? Automobile is already existing and is containing all the generic features of all the automobiles, right? So when automobile is existing, from this you can create a new class two wheeler, and you can add some more specificity into it. You can add a few more specific things which are specific to two wheelers, and further you will create a new class geared using two wheelers. So it will create a kind of hierarchy. Inheritance is clear, beta? Yes, inheritance is
Yes,
clear.
sir.
Yes,
Okay.
sir.
Yes,
So
sir.
the first class is called base class. We call it a uh, base class, and the next level class is called derived class. Base class is also known as parent class, and derived class is also known as child class, right? Then last concept is polymorphism. Anybody? What is polymorphism? Multiple forms it means. For example, in Java, in Python, even in Java, uh, plus operator has got multiple meanings. It is used for adding numbers. It is also used for concatenating strings. And then, if it is possible to define some more behavior of an operator, for example, plus, if we are able to add two dates, two distances, or any kind of two similar data, then we call it polymorphism, right? It will have multiple forms. Is this thing clear, Bajay? Is this thing clear?
Yes, sir.
Yes.
Okay. Now let's see some examples of it. Let me declare a class. So concentrate that how do we do it. So we'll write here class. We'll name it test. So a class, what is a class? It is basically a user defined data type. Okay, it is a user defined data type through which we are implementing object oriented programming. Okay, uh, so there in a class there is a special function, we also call it a uh, constructor. We call it a constructor, right? uh, it is written like this: def two underscores, init again two underscores, and within bracket self, right? This is a constructor. Okay, so within this we can declare uh, members of the class. Self dot a is equal to 10, self dot b is equal to 20. So we have declared two members of this class, a and b. Okay, it's a very simple class. So next, let us have a function display. Again, self. Uh, Here we'll write. I missed it here. Okay, here we'll write print self dot a and self dot b. So this is a very simple class with two data members a and b and two functions. First is constructor, right? It's a special function, and second is a normal function display. So this class is declaration is complete here. Now we can use it. I told you that just like any other data type, a class is also a data type, but it is a user defined data type. Okay. So let me create an object of it. Say t is equal to test. Just a minute, but I'm getting a call. So this is how we declare or we create an object. We'll write t is equal to test. Then through this we will call the function display. So let us have a look at it, how it works. You can see. So when you create an object, then the constructor is automatically called there, right? So constructor is what? It is a special member function which is automatically called whenever an object of the class is created. Is this thing clear, bache? Constructor is clear. I'll
Yes,
Yes,
sir.
sir.
okay. I'll repeat. Still, I'll repeat. A constructor is a special member function which is automatically called whenever object of the class is created. Now, there's something special about the constructor. It is preceded and followed by two underscores. So anything in Python which is preceded and followed by two underscore is something special. It means its meaning is reserved in the language. Don't use it for any other purpose. Okay, it's a very simple example, very simple example. We can even have a different constructor like x is equal to 10, y is equal to 20. Now, what is the meaning of this? We are providing two parameters also. Now, here I am creating one object t1, another is t2 is equal to test, and I am passing parameters 100 and 200. And then I'm calling t1 dot display and then t2 dot display. So what will happen? In case of T1, since we are not passing any parameter to the class, so X will remain 10, Y will remain 20, A will become X, which is 10, B will become Y, which is 20. So for T1, the values are 10 and 20. But in case of T2, at the time of creating this object, we are passing two parameters, 100 and 200. So X and Y will get these values 100 and 200. Otherwise, if you are not passing these as parameters, then X and Y will assume their default values. So in case of T2, the values of A and B will be, yes, anybody? The values will be 100 and 200. You can see
100
it.
and 200, sir.
Very good, very good. You can see it here. For T1, it is 10 and 20. For T2, it is 100 and 200. Is this thing clear, bache? Is this thing clear?
Yes, sir.
Okay.
Yes, sir.
What is the meaning of self here? Self basically represents the object. These two, T1 and T2, are objects of the class. So what I'm going to do, I'll print the ID is, I'll print the IDs. ID means their memory address, right? ID self. So let's see what will happen in both the cases. It should be small ID, small ID. Okay. You can see for T1, ID is different. For T2, the ID is different, right? It means T1 and T2 will have different memory areas. So self, I repeat, self means the object which you have created. So when we say self dot A, it means for that particular object we are referring A. For that particular object we are referring B. Like in case of T1, when you're calling display through T1, so self would mean T1. It means it will contain the address of T1. And in case of T2, it will contain the address of T2. Is this thing clear, bache?
Yes, sir.
Okay.
एक बार repeat करें हो?
But self means the object which you have created. It contains the address of that object, right? So when you are calling, when you have created T1, it will be allocated memory. When you will create T2, it will be allocated a separate memory, right? For example, in C, when you write int A, it means A is of type integer and memory will be allocated to it. So I told you that a class in itself is nothing. It is just a user-defined data type, right? So when you want to use it, you need to create variables of that type. So here we are creating a variable of type test T1, right? Here we are creating a variable T2 of type test. So when you'll create these and then you're calling T1.display. So in this display, since we have specified self here, what it will do, it will print A and B of that self. Which self is it? T1, right? Self is representing T1 here. When you will call display function through T2, self would mean T2. So self is basically representing the object. Is it clear now, Nitin?
Yes, sir.
Okay. Uh, in this case, what we have done some data abstraction and some functional abstraction. Then we put these things together in an entity called test. So this is called encapsulation, right? So what is data hiding then? How can we declare private members? By default, all members of the class are public. For example, have a look here. If I write here print uh, test.a, will it work? Print test.a. It won't work. Why? Anybody? Do you have any idea why it's not working? Okay, well, I'll explain it to you. Let us save this object-oriented programming 01. Okay, and let me copy the code. We'll move to the second program then. Okay, here. Now, you need to understand a few things which are very, very important here. First is these two variables which we have declared, they are data members of the class. Okay, they are instance attributes, means they will belong to a particular instance. Here, if I declare integer, or sorry, some variable, say I is equal to 10, j is equal to 2, I is equal to 1, j is equal to 2. These attributes are class attributes, right? And here A and B, these attributes are instance attributes. What is the difference now? In case of instance attribute, each instance will have its own set of attributes, right? For example, let me tell you here. Suppose you have created a class test here, right? And in this, you have declared A and B as instance attributes, right? A and B are instance attributes here. Then from this, you have created a class, an object T1 and an object T2. So what will happen? Since A and B are instance attributes, T1 will have its own A and B, and T2 will have its own A and B. And if in class test I and J are class attributes, it means they will be shared by every instance of the class. Every object of the class will share the class attributes. Now have a look at it. We'll continue with the class. Okay. We'll have second session also. If in case it stops, then join back again. Okay. Uh, so the basic difference between instance attributes and class attributes is instance attributes are not shared. Every object will have its own set of instance attributes, whereas class attributes are shared by all the classes, all the objects of the class, and they are common. Now, have a look at it again. In display, if I write here values of I and j as well. Now look at it. I am not writing self I and self j, because if I write self, then it means I am referring to instance attributes, whereas I and j are class attributes. Wait a minute. Okay, fine. The problem lies here. The problem lies in the method. I'll write here def show. I'll create another function and then I'll print values of I and j. Let's see whether they work or not. Still not working. So what we need to do, we need to write here CLS and then CLS dot and here also CLS dot. There's a difference between these two functions. Once again, this is instance method. This is an instance method, and this one is a class method. I'll explain it. First, let us see what will happen. I'm writing T1 dot show, and then I'm writing T2 dot show. Let's run it again. As you can see, for show, it is showing 1 and 2. Now, when we have class attributes in a class, we can access those class attributes directly through class name as well. I can write here print test.I and test.j. Let me remove these show functions here. So you'll be able to see that these are visible outside the class also. Is this thing clear? Is this thing clear? Yes. If it is not clear, still let me know. But respond.
Clear, sir.
Okay. Now, what is the difference between instance method and class method? I hope you remember uh, we had used uh, square root function, we had used randint function, and maybe a few more. This is from math library, and the second one is from random library. So when we use randint, then it is a class function. We can without creating any object of random class, we were able to use randint, or without using any object of math class, we were able to use square root, because to square root you will pass a parameter, right? And it will find the square root of that particular parameter. There's no in nothing like instance attribute which is required for square root. It is not required at all. It will work on external data. Similarly, randint. So what we can do in Python, we have a facility. Instead of putting a comment, I'll write here @ class method. Then it means show is a class method, right? Similarly, we can have static methods also. Static method and class methods can be called without creating any object of the class. So let me write here def, I'll name it, say some string, right? So what we'll do, we'll write print hello and some string. So here I'll call this function. I told you that class methods and static methods can be called using name of the class only. We need not to create objects of this. We need not to create objects for using these. For example, if I write test test dot show, we have not created any object of the class. Still it is working. It is showing us the value of class attributes I and j, which is 1 and 2. Similarly, if I call test dot say some name, let it be Palak. Let's say, what will it do? It will write hello Palak. So you can see it here. We have called these two functions. First one is a class method. Second one is a static method. But it doesn't mean that you cannot call these through the objects. Once again, T1 is equal to test. T2 is equal to test. We are creating two objects now. Once again, 100 and 200. And here I am writing T1 dot display. I'm writing T2 dot display. And then I'm writing T1 dot show, which is perfectly valid. It will work. You can see it here. So for T1, it is showing its ID and the values. Since we are not passing any parameters, A and B will get 10 and 20. In case of second call, which is through T2, we are passing two parameters, 100 and 200. So A and B will become 100 and 200. Then we are calling T1 dot show. Since show is a class method, right? It will display the values of I and j. You can see it is showing 1 and 2. And then we are again calling show through class name without using any object. Again, it is showing 1 and 2. And finally, we are calling the static method. And here it is saying hello Palak. But is this thing clear?
Yes, sir.
Yes, sir.
Okay, good. Any doubt up to this point? Any doubt of any kind? Yes.
No, sir.
Are you
No,
sure?
sir.
Sure. Okay. Uh, let's move to the next one. I'll name it as object-oriented programming 02. Let's move to the next part. Let me remove all these. Okay. Then is, I told you that all the variable, all these are basically uh, public, right? Everything is public here. I have removed the other methods. So let us focus on this. I am removing these class attributes as well. So we have instance attributes only. And here, once again, I am creating T1 is equal to test and T2 is equal to test 100 and 200. Okay. If I write here print T1 dot A or T1 dot B, because A and B instance attributes are by default, I told you everything in a class is public. Public means it can be accessed outside the class also. Here you can see I've been able to use A and B instance attributes of class test through its object. Similarly, we can use T2. If I write here T2, then I'll be able to access instance attributes of T2 also, right? So how to make something public? So there is a very peculiar way in Python. You need to put two underscores here and the instance attribute will become public. Sorry, private. It will become private. So let me write it here, private member. And now you try to access it here.